I mean, there's so much that you can learn from black holes. Black holes are the ultimate laboratory for conditions that we can't recreate here on Earth. They're a great test for gravitational waves, they're a great test for general relativity, also particle physics for, interactions close to the black hole as well.
We are trying to find stellar mass black holes that are in binary systems with other stars. So these are black holes that are orbiting with stars, so the black hole and the star are orbiting each other.
So whether we find them or we don't, this is going to be a huge discovery for science.
Let me tell you what Black Hole Hunters is about then. So we predict there should be millions of hidden black holes within our galaxy. They're orbiting with a companion star, and when they edge onto us, they're going to bend the light of that companion star around the black hole, and we're going to see an increase in the light. We call it self-lensing.
And if things are lined up just right, then every time the black hole passes in front of the star, it can act a bit like a magnifying glass and make the star look brighter for a little while. And we're looking for those events. We're looking for that telltale increase in brightness that would indicate that there might be a stellar mass black hole passing in front of a given star.
And what we're asking citizen scientists to do is search through huge amounts of data which have been taken by a planet hunting satellite called TESS, and we're asking them to look for these signature changes in the light that tell us there might be a black hole located there.
The Black Hole Hunters project is an online citizen science project hosted on the Zooniverse platform, which allows any members of the public to help us in our search for black holes just by using your computer or smartphone or tablet at home. You don't need any special training or special equipment to help us. All you need to do is use your web browser and click on the link to the project in the description for this video.
You'll find a tutorial where it shows you exactly where and what to click to report your findings and come and talk to us. But most importantly, if you see a nice big symmetric peak that looks promising, click on it because you might have just found the next black hole.
Now you might argue, well, why don't we just use artificial intelligence? Computers are not infallible and they don't always find things. The human eye and the human brain are very good at looking for signals, especially when data is missing. Citizen scientists are a really important element of this. They can go through the data and they can say, oh no, there is an event there, and the computer might have missed that. So they're a completely independent search method for these systems. But we need a lot of people. There's a huge amount of data, and so we want as many people as possible to volunteer and to help us find these self-lensing black holes.
So the reason we're doing this project is that there should be loads of these black holes out there in the Milky Way that we haven't found yet. We only know about maybe 20 stellar mass black holes for certain, and there's maybe 70 or so candidates. But we think there should be millions or maybe even tens of millions of these objects in the galaxy. So we're missing a huge part of that population. We don't know about most of these objects. The self-lensing signature that we're looking for is one way that we can find that, and it should be quite obvious. Given enough data, we should be able to find quite a lot of examples of this.
So I'm the lead of the Cobalt Network. That comprises quite a large number of scientists across the globe. So I'm very lucky to have these really great people who are helping me realize my dream of finding these self-lensing systems. But in order to take it to that next step, we need thousands of people to actually go through the data. We can't do that on our own.
If you choose to take part in the Black Hole Hunters project, you won't be working alone. We've got a community of nearly 9,000 other volunteers. And the way it works is we show each light curve to more than one person. So currently we show each one to 15 people, and we put all their answers together at the end and come up with a consensus answer for each one. You can also talk to the other volunteers, so you don't have to work in isolation. There is a discussion area. We're on there as well. I'm on there almost every day talking to our volunteers. So why don't you come and join the community, and not only can you meet other people who are interested in astronomy and in black holes, you can potentially make a big scientific discovery while you're doing it.
What we need you to do is to help us find these self-lensing events so that our scientists can study them in more detail and get you guys involved in helping us to find these hidden black holes.
You might be the one that helps us uncover these hidden black holes. You could be part of discovering this whole new population of black holes that we haven't found yet.
Whatever free time you've got, you're willing to devote to this bit of exciting science, we're really appreciative of. There is a lot of data to search through, so you're not going to run out. Yeah, you could be the person who finds the very first self-lensing black hole, and you'd be acknowledged and part of the paper, the publication that goes forwards. So you could have your name attached to a seriously major discovery in modern physics.